Okay, here's a PowerPoint on plate tectonics and the inner Earth, something that I can't be here for, but I'm going to show you anyway. You can think of the Earth as having the crust that's broken into plates, so we're going to talk about that and the evidence we have for that. And I can't move my slide. There we go. First thing I want to do is show you some evidence on a live earthquake map. So these are earthquakes that are happening right now, and it's 4:30 on the 3rd. So these are after school earthquakes, and if we pull back out, these are earthquakes of 2.5 magnitude or greater. And we keep pulling back, you can see there's earthquakes that have happened today. And we can change this. Every year it's a little different. Let's see if I can get this, move this out of the way. Still trying to remember how to change it. Nope. Settings, let's go 7 days. All magnitudes in the United States. Okay, go back to the map, which I don't know how to do. This is a disaster, as usual. There we go. So, this is the earthquakes in the world in the last week of all magnitudes. You can see some larger ones here. Magnitude is 6.4 in Russia. See tons of them here, tons of them here. Let's go back into the United States and look closer. You see a lot of them right here, or a relative number right here. And then this area, which I've never honestly seen before, showing up that many earthquakes, that is Yellowstone area. Usually I see some, but not that many. And it just shifted to something. I don't know what it did. Okay, so those are live earthquakes, so we think the Earth must have some problem with it because of the fact that it's got all these earthquakes. Alright, next, you know the Earth has got these parts. The crust being the outer, mantle is this next layer, and then two cores, which you've already read about. The inner core, outer core, mantle all have their own depths, of course, the crust being the thinnest of them all and the mantle being the thickest. So the theory is that the crust of the Earth is broken into plates, and just like I had you do water, hot and cold water, and show how hot water rose, same thing happens in the mantle with rock, and it's really hard to believe, but the mantle's kind of squishy and movie and plasticky, and it can move around. Now, how do we know this? Well, we have to look for some data. So I'm going to have you look at some maps. This map is called seismology, and you're going to take a close look with a partner at this. This is the earthquake map, and you're going to note patterns. Be sure to look very carefully at patterns. Then you're going to look at the volcano map. This map also has some patterns, and again you have to kind of fine-tune. Don't just look at land, look at ocean for volcano map. Then this one always does people in, so that's why I'm explaining it. You have to look for this is the high points of the Earth, very high altitude. This is very, very low points in the Earth. And here's the Himalayan mountains, so you can see those are high. But there are other high points that aren't exactly on land, so take a look at those. And this is another map that students have a hard time understanding. This blue indicates very old rock, and this red indicates rock that is brand new, that is bubbling up from the cores of the Earth. So again, you're going to look at patterns of old versus new. You're going to look at patterns of altitude and lowtude. I made that word up. And you're going to look at patterns of volcanoes and patterns of earthquakes to try to indicate where the plate boundaries are. So I'm going to stop there and let you do your activity on plate tectonics, and then I will start up again. Okay, now that you've looked at your maps, we're going to go back and take a look at what the patterns that you found. Hopefully you saw some patterns that indicate that there are lots of earthquakes along a boundary right around here. There's some earthquakes here. Of course, there's tons here and here. Then you see these little dotted lines here. Yep, this one I liked because it kind of looks like the shape of Africa right here. And this happens to be an interesting part of the ocean we'll talk about in a minute. I want this slide to go. So that's that. And then the volcano map tends to show some of the same patterns, not all of the same patterns, which I'm sure you saw. And then you probably saw very high points here, but you also saw high points here and here. And this happens to be a giant crack in the earth called the Mariana Trench. And I have a really nice 3D map up front on the bulletin board, and you can look at that and actually feel the different plates that are there. But this trench is goes down very low, and also its height is every bit as high as the Himalayan mountains. If you watch SpongeBob, this is a trench that he looked for the ocean bullworm, I think it was, in. Now this one's really hard to understand, I think, for most people, but you notice that new rock, new earth, new crust is being formed right here, and as it's being formed, it bubbles up from the bottom, it pushes to the right and left, and pushes this rock out to the side. So new crust is built, old crust gets pushed out, and so you can see at the boundary of Africa and the boundary of North America and other places is older rock, and this is newer rock. Well, as this old rock hits Africa, it causes earthquakes and so on. Same here with the North American or the Atlantic plate hitting the North American plate. So all these things cause movement in the earth. We know these things happen because we've gone down here to see this happening. We also can dive down here. I have some cool pictures of the plate boundaries here, and we also know the earth is moving because we have earthquakes and volcanoes. Okay, and so when you got your basic map of the earth and drew in your plates, you probably didn't come in with 16 plates. I think that's really hard to do, but there's a lot of plates that they have mapped out based on inferences from the data. So here's what you need to know. Here's the test question down here. What is plate tectonics and what is the evidence? So you can pause here and write down that question if you want. I will proceed on to talk about the theory and the evidence, and then maybe you want to pause the whole thing and write it down. So the theory of plate tectonics is that the Earth's crust is divided into plates, the plates move, and the crust is both diving under plates and gaining as we look at the ocean floor. The evidence is active volcanoes, the pattern of the old crust versus the new crust in the ocean, the earthquake data, and the general shape of the plates look very similar. They look like puzzle pieces. So the question is, how do we know that the continents drift and move? Well, we can go down there and look. Isn't that cool? Between Iceland and North American, and between the North American and Eurasian plates. Check this one out. A giant crack. Now this is not between two plates. This is right in the middle of California. It's called a fault line, and it's where the plates have a crack in them. But we know that fault moves. We see rocks in Australia that are unrelated to any other rocks in Australia. They're related to rocks in North America, and therefore we think, oh my gosh, we're North America and Australia together at some point. We go down under the ocean, we see these very cool lava vents called hydrothermal vents that spew out new crust on the ocean floor. And we can see that these plates move. Check out this picture. That's so cool. Here's the Mariana Trench. This is that central Atlantic Trench. And here's Mount Everest on top of it. So you can see it's really, really big fissure in the crust. Oh yeah, here's SpongeBob looking at it. The Alaskan bullworm, that's what it was. So now we're going to look for evidence the crusts may or may not have been together. And I'm going to stop here.